Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to convert Fahrenheit to Celsius, which is something you need to know how to do in order to be successful on the Armed Services Vocational Aptitude Battery, that is the ASVAB. More specifically, I'm going to work through 4 different practice problems. And if this is your first time finding my YouTube channel, I always stress that in order to get the most out of my videos, you need to work out as many problems in my video as possible. So if you're good at math already, you can simply work through these 4 practice problems on your own and use my video to check your solution. Otherwise, I'd strongly encourage you to watch how I work out the first problem and then attempt to work out the next 3 problems on your own. And one final thing before we get started, there is a formula that you have to use in order to convert from Fahrenheit to Celsius. That said, it's not one that I recommend you memorize. In my experience, this formula will be given to you on the test. So as long as you can use the formula to solve the question, you should be good to go on test day. So all that being said, let's go ahead and get started with today's video. All right, so since the formula that you need to convert from Fahrenheit to Celsius is very simple and straightforward, I'm not going to spend any time in this video discussing the ins and outs of it. As you'll see in just a few minutes, all you do is have to identify Fahrenheit and plug it in accordingly. So instead, I'm going to get started working out these practice problems. And this first one, as you can see, says hypothermia is a medical emergency that occurs when your body loses heat faster than it can produce heat, causing a dangerously low body temperature. Normal body temperature is around 98.6 degrees Fahrenheit. Hypothermia occurs as your body temperature falls below 95 degrees Fahrenheit. When does hypothermia occur in terms of Celsius? Use Celsius equals 5 over 9 times Fahrenheit minus 32. All right, so if I was taking the ASVAB, the very first thing I would do is take this formula that's given and write it down on my own scratch paper. So let's go ahead and do that to start. We have Celsius equals 5 over 9 times Fahrenheit minus 32. All right, so as we can see, in order to use this formula, the only thing we have to identify is Fahrenheit. And in this case, we want to know when hypothermia occurs. Well, we're told that occurs when the temperature of the body falls below 95 degrees. So F in this case is going to be 95. All right, so with those things identified, let's plug it in and solve this equation accordingly. We have Celsius equals 5 over 9 times Fahrenheit is 95 minus 32. All right, so according to the order of operations, we work out what's in parentheses before we do multiplication. So I'm going to work out this 95 minus 32 first. And I'm going to do that off to the side so as not to make any mistakes here. So we have 95 minus 32. 5 minus 2 is 3. 9 minus 3 is 6. So this becomes Celsius equals 5 over 9 times 63. All right. So at this point, we can rewrite this such that it becomes a little bit clearer as to what's going on. More specifically, at this point, we can go ahead and drop those parentheses, and instead we'll write in a multiplication symbol. So this is 5 over 9 times 63. That said, you can see that we're multiplying a fraction, notably 5 over 9, by a whole number. Well, if you watched my video on fractions, you'd realize that we can quickly write 63 as a fraction by placing it over 1. And when you multiply fractions, you typically just multiply straight across. That said, in this case, this one's a little bit easier than that because you may have noticed that both 63 and 9 have a common factor of 9. That is to say, 9 goes into 9 one time, and 9 goes into 63 7 times. Okay, so we reduce this one to be this. 5 over 1 times 7 over 1. And anything divided by 1 is itself. So 5 over 1 is just 5, and 7 over 1 is just 7. So we can actually rewrite this as 5 times 7. 5 times 7, we should know, is 35. So the answer to this one is hypothermia occurs at 35 degrees Celsius, which is the equivalent of 95 degrees Fahrenheit. And as you saw, in order to use this formula, we first had to identify our F, and then after that, we had to be confident in our ability to work with fractions here in order to solve for C. And that's pretty much all there is to these problems. A lot of people get tripped up when they get to these fractions. And so in light of that, let's go ahead and take a look at another problem. All right, so this next problem says a thermometer in a science lab displays the temperature only in Fahrenheit. If the mercury in the thermometer rises to 56 degrees Fahrenheit, what is its corresponding Celsius temperature? Again, we're given the formula to make the necessary conversion. Notably, Celsius equals 5 over 9 times Fahrenheit minus 32 in parentheses. Again, if I were taking this test, the very first thing I would do is copy down the formula that I'm given. So on my scratch paper, I would write Celsius equals 5 over 9 times Fahrenheit minus 32. Now that I've written down the formula, I'm going to go ahead and identify what Fahrenheit is so I can plug it into the formula accordingly. And according to this problem, we're trying to convert 56 degrees Fahrenheit to be in terms of Celsius. So let's go ahead and plug that in now. We have Celsius equals 5 over 9 times, again, Fahrenheit, our F is 56, so this becomes 56 minus 32. So at this point, we're left with this equation, 5 over 9 times parentheses 56 minus 32. According to the order of operations, we're going to work out what's in parentheses first, and then we'll take care of this multiplication. And if you need to see the order of operations, let me go ahead and write those out for you. Again, the order of operations are best remembered by the acronym PEMDAS, or Please Excuse My Dear Aunt Sally. This tells you the order in which to work out problems like this. You do what's in parentheses first, then exponents, then multiplication and division as they appear from left to right, and finally addition and subtraction as they appear from left to right. In this case, we have parentheses, so we'll do those first, and then after that, we'll do our multiplication. So in an effort not to make any simple math mistakes, I like to do simple addition and subtraction off to the side. So I'm going to do 56 minus 32 off to the side like this. 6 minus 2 is 4. 5 minus 3 is 2. So this becomes 5 over 9 times 24. And at this point, we can go ahead and drop those parentheses so it's a little bit clearer as to what's going on in this problem. And you could have dropped those parentheses right here if you wanted to, but I'm not going to skip any steps as I work out these problems. So we have 5 over 9 times 24. And at this point, you should see that we're multiplying a fraction, notably 5/9, by a whole number, notably 24. When you multiply fractions, you simply multiply straight across. That said, we need to add a denominator to 24 in order to do that. Well, all whole numbers can be written as fractions by placing them over 1. So if I wanted to write 8 as a fraction, I would simply place it over 1. Again, 8 divided by 1 is just 8, and that's the reason that works. So I'm going to go ahead and write 24 as 24 over 1, which is going to enable me to multiply these fractions. And before I do this math where I multiply straight across, I want to try to simplify this if possible. Well, I know 3 goes into 9 3 times, and I know 3 goes into 24 8 times. So clearly 9 and 24 have a common factor of 3, and we can use that to reduce them. 9 divided by 3 is 3. 24 divided by 3 is 8. And you want to do that wherever possible because the math will become a little bit easier to work out. So let's rewrite this so it looks a little bit neater. This says 5 over 3 times 8 over 1. All right, so now we're multiplying two fractions, in which case we're going to multiply straight across. So this is going to become 5 times 8 over 3 times 1. 5 times 8, you should know, is going to be 40 over 3. All right, so you're probably saying to yourself, well, that doesn't look like a correct answer. Well, as I stress in all my videos, you can regard 40 over 3 as a fraction, or you can regard it as long division, in which case you can convert it to a whole number or a decimal. So I'm going to regard this as long division, and I'm going to read this as 40 divided by 3. All right, so we start by asking ourselves here, how many times does 3 go into 4? That's 1 time. 1 times 3 is 3. 4 minus 3 is 1, and now we can drop down this 0. How many times does 3 go into 10 without going over? Well, 3 times 3 is 9, and 3 times 4 is 12, which is too big, so this is going to be 3. 3 times 3 is 9. 10 minus 9 is 1. And now we're asking ourselves if 3 goes into 1. It doesn't. So we're going to have to add a decimal. And we can add a couple 0 placeholders here. And right now we can drop down one of them. How many times does 3 go into 10? And let me backtrack a little bit. Once you add that decimal, you want to bring it up right here. Okay? So now the question is, how many times does 3 go into 10 without going over? We saw that that was 3. Again, 3 times 3 is 9. 10 minus 9 is 1. We can drop down one of these zeros. 3 goes into 10 3 times without going over. 3 times 3 is 9. And as we can see, this is just going to repeat over and over again. So we would say that the temperature in terms of Celsius is 13.33 degrees. Repeat it, are 13 and 1/3 degrees. All right, so either of those two are acceptable. And so the answer to this problem is 56 degrees Fahrenheit is the equivalent of 13.33 degrees Celsius. All right, and again, the difficulty of these problems is you have to work with fractions, and then at some point, you're going to have to convert your fraction back into a decimal, which requires you to be good with long division as well. Okay, so if you struggle with fractions and decimals, please check out those videos on my channel. They're some of my most highly rated videos. I think one of them has over 20,000 views at this point, and I just posted a couple months ago. So again, check out those videos. They will help you tremendously. And I'll put links to those videos in the description of this video. All right, so number 3 here says on January 19th, 1977, Florida residents and visitors were both surprised and thrilled by a once-in-a-lifetime event. Snow was seen falling across all of southeast Florida, including as far south as Homestead and even on Miami Beach. If the lowest temperature that day on North Miami Beach was recorded at 25 degrees Fahrenheit, what was the temperature in terms of Celsius? Again, we're given the formula, notably Celsius equals 5 over 9 times Fahrenheit minus 32. So not surprisingly, I'm going to start this one by copying down the formula that was given. So Celsius equals 5 over 9 times Fahrenheit minus 32. And next, you want to identify what you're going to plug in place of F there. And in this problem, we're told that we want to convert 25 degrees Fahrenheit to be in terms of Celsius. So let's go ahead and plug that in now. We have Celsius equals 5 over 9 times 25 minus 32. Again, according to the order of operations, you're going to work out what's in parentheses before you do this multiplication here. So in other words, we have to work out 25 minus 32. All right, so in this case, we know our result's going to be negative. That said, in order to do this subtraction by hand, we actually have to do this. We actually have to do 32 minus 25. Okay, and I already accounted for the fact that our answer is going to be negative here. So let's go ahead and work this out. 2 minus 5 we can't do, so we have to borrow. This becomes 2, this becomes 12. 12 minus 5 is going to be 7, and 2 minus 2 is nothing, so this becomes negative 7. I recently created a video in which I discuss how to add and subtract integers. So if you got stuck right here, you may want to check out that video. I work out quite a few practice problems in that video, and it should be pretty helpful. That said, now we have this problem, 5/9 times negative 7. Of course, let's rewrite this without the parentheses, so it's a little bit clearer as to what's going on. We have 5/9 times negative 7. That is to say, we're multiplying a fraction by a whole number. In order to proceed, we want to rewrite this whole number as a fraction as well by placing it over 1. And in this case, we have a positive times a negative. So I know right away, a positive times a negative is going to result in a negative. That said, if we look through these two fractions, we can see that we really can't simplify this one at all. So we're going to have to just do our multiplication accordingly. And when you multiply fractions, you multiply straight across. That is to say, you would do 5 times 7, and I accounted for the negative over here, so don't worry about that. And then 9 times 1. All right, so with that done, let's keep working it out. We have Celsius equals negative 5 times 7 is 35. 9 times 1 is just 9. And at this point, you're probably saying to yourself, well, this doesn't look like a correct answer. Of course, we can always treat fractions as long division. So I could read this as 35 over 9 as a fraction, or I could read it as 35 divided by 9 as long division. When you treat it as long division, that's going to enable you to convert the fraction to a decimal. So again, we know our answer is going to be negative, but that said, we want to make this conversion. So let's read this as 35 divided by 9. All right. So we start this one by asking ourselves, how many times does 9 go into 3? It doesn't. How many times does 9 go into 35 without going over? Well, 9 times 4 is 36, so that's too big. So this is going to have to be 3. 9 times 3 is 27, and we'll go ahead and subtract that out. 5 minus 7 we can't do, so we have to borrow. This becomes 2, and this becomes 15. 15 minus 7 is 8. 2 minus 2 is nothing. So at this point, you're probably saying to yourself, well, how many times does 9 go into 8 now? It doesn't. So what we have to do is add a decimal. And once we add that decimal, we want to bring it up here. And now we can add a few 0 placeholders so that we can continue doing this long division by hand. And as a matter of fact, we're going to go ahead and drop down one of them. All right, so now the question is, how many times does 9 go into 80? Well, 9 times 9 would be 81, and 9 times 8 would be 72. So this is going to be 8. 9 times 8 is 72. 80 minus 72 is 8. So we're going to drop down another 0. Again, 9 goes into 80. 8 times. 9 times 8 is 72. 80 minus 72 is 8. So we can see that this is going to repeat over and over again. So this is going to be 3.88888. Repeat it. So in other words, Negative 35 over 9 is the same as negative 3.88 repeated. All right. And so the answer to this question is 25 degrees Fahrenheit is the same as negative 3.88 degrees Celsius. All right, and as you saw, we had to work with subtraction involving integers, multiplication involving fractions, and then we had to convert a fraction to a decimal using long division. Again, that's why these problems show up on the ASVAB. If you can't do one of those three things, these problems are pretty difficult, but otherwise they're pretty simple. All right, so number 4 here says a thermometer in a science lab displays the temperature only in Fahrenheit. If the mercury in the thermometer rises to 100.4 degrees Fahrenheit, what is its corresponding Celsius temperature? Of course, we're provided the formula to make that conversion. Notably, Celsius equals 5 over 9 times Fahrenheit minus 32. So the very first thing I'm going to do, not surprisingly, is copy down the formula that I'm given. Notably, Celsius equals 5 over 9 times Fahrenheit minus 32. I'm going to identify what F is. And according to this problem, we want to convert 100.4 degrees Fahrenheit to be in terms of Celsius. So that's our F. With that identified, let's go ahead and plug it in now. We have 5 over 9 times 100.4 minus 32. All right, according to the order of operations, we have to work out what's in parentheses first before we do this multiplication here. So let's work this off to the side. We have 100.4 minus 32. And you're probably saying to yourself at this point, well, how am I going to subtract a decimal by a whole number? That's easy enough. We can actually add a decimal after this 32 and a 0 placeholder. Again, let me just explain what I did there. I can write 32 as a decimal by placing a decimal at the end of it and adding as many zeros as I want. Again, this value says 32, and that's what I did here. I only needed one of those zeros. So with that done, let's go ahead and work this out. We have 4 minus 0, which is just 4. Drop down your decimal in place. 0 minus 2 we can't do. We have to borrow, but we can't borrow from this because it's 0. So we're going to have to come all the way over here and borrow from that 1. This becomes 0 now, and this becomes 10. And then we have to borrow one more time, so this will become 9, and this will become 10. 10 minus 2 is 8. 9 minus 3 is 6. And then 0 minus nothing is 0. So we can see that this becomes 5 over 9 times 68.4. All right, so let me go ahead and rewrite this without the parentheses. I know many of you could have probably skipped that step, but I'm working out every step because some people need to see it. So this is 5 over 9 times 68.4. Again, we're multiplying a whole number by a decimal here. So what I want to do is write this decimal as a fraction by placing it over 1. And that's going to enable me to do this math very quickly. And unfortunately, I can't reduce anything here, so I'm going to have to multiply straight across. That is to say, this is going to become 5 times 68.4 over, let me put that up there a little better, times 9 times 1. Well, 9 times 1 is easy. Anything times 1 is itself, so that's just 9. But that said, I have to work this off to the side. This is 68.4 times 5. All right, so we're multiplying a decimal by a whole number. And if you watched my video on decimals, which I strongly encourage you to do so, you'd realize that in order to make this math a little bit easier, what we're going to do is we're going to shift this decimal place one time to the right such that this becomes 684 times 5 with no decimals. And once we work that out, we'll shift that decimal place one time back into the left. All right, so let's do that. 5 times 4 is 20, so we'll drop down a 0 and carry a 2. 8 times 5 is 40, plus 2 is 42, so we'll drop down a 2 and carry a 4. 6 times 5 is 30, plus 4 is 34. Bring our 1 decimal back in. So this becomes 342 over 9. All right, and again, we're going to regard this fraction as the long division, which will enable us to convert this fraction into a decimal, which our answer is probably going to be given as. So let's go ahead and do that over here. We can read this as 342 divided by 9. I hope this works out evenly. Now the question is, how many times does 9 go into 3? It doesn't. How many times does 9 go into 34 without going over? Well, 9 times 3 is 27, whereas 9 times 4 is 36. So this is going to be 3. Again, 9 times 3 is 27. Let's subtract this out now. 4 minus 7 we can't do, so we're going to have to borrow. This is going to become 2, and this is going to become 14. 14 minus 7 is going to be 7, and 2 minus 2 is nothing. That said, we got to drop down this 2 now. 9 goes into 72 8 times. 9 times 8 is 72 with no remainder. Therefore, we can see 342 divided by 9 is 38. In other words, 100.4 degrees Fahrenheit is the same as 38 degrees Celsius. All right, so that is it for today's video. As always, I hope you found this video helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Before I end today's video, let me just stress this. I do things in my videos in an effort to fully prepare you for the ASVAB, and I don't see those things occurring in any other place on YouTube. And let me just share with you some of the logic behind this video, for example. So when you teach, you always want to start with a question that is in simplest form. And as you saw, this first question here didn't really involve any tricky math or any tricky ideas whatsoever. So this first question I wrote to be the easiest question in today's video. After that, I ramped up the difficulty a little bit, and more specifically, I made you, at the very end of this problem, convert a fraction into a repeating decimal. So that's one step above the previous problem in terms of difficulty. Then I threw in this right here, where I forced you to work with subtraction that resulted in a negative. And then after that, you had to convert a fraction to another repeating decimal. So this is 2 steps above the previous problem. And then finally, in this last problem, I threw in a decimal, which you had to perform subtraction with right here. Then you had to perform multiplication with it right here. And then you had to convert this fraction. So 3 steps above the first problem. So again, there aren't a lot of people making an effort to do that in their videos. And for that reason, I hope you appreciate what I'm doing. And if you do, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose for the day.